Some examples on finding quadratic models. So in this case, we have the number of Home Depot stores has increased greatly since 1985. Let f of t be the number of Home Depot stores at t years since 1985. Something to be aware. You may have done several or many types of problems similar to this one now in the past. So we have our four-step modeling process. To find a model and make estimates and predictions, 1. Create a scattergram of the data. Decide whether a line, an exponential curve, a parabola, or not that this comes close to the points. 2. Find an equation of your model. 3. Check that the equation is a good approximation to the model. If it does not fit the model, check for errors, or think about an alternate from choice of step 1. 4. Use the equation to draw conclusions and make estimates and or make predictions. Okay, so let's try to do a scattergram of the previous. So the first thing we gotta realize, we want to convert whenever we have tables with years to singular years. So my table from the left, by comparison to the right, all we've done is updated the years to be singular years. Notice that it started since 1985. So therefore our starting year is 1985, which is a year to 0 by definition. So that's my first number on the table there, 0. Then 1988, since 1985 it's been 3 years. 1991, 6 years, etc. Note that the number of stores, it remains the same in both tables. So let's plot our table. So there we go. I've chosen a one-sided quadrant graph, meaning a single quadrant, because they're all positive numbers. So at the bottom, I have my increments are going by essentially ones all the way up to 20. And on the left side, I've selected to go up by 100. So 100 increments, 100 of an increment. Let's label our X and Y axis as well. And for this one, how about if we put a title on there? This talks about the number of Home Depot stores. So let's say Home Depot stores increase. And now let's search plot that. 0, 50 is the first coordinate point. So 0, 50 is our y-intercept. There we go. 3 and 96, there is our next coordinate point, 396. 6 and 174, there it is. 9 and 340, there's our next point. 12 and 624, there we go. 12 and roughly 624. Notice my values on my graph are very basic, very rough approximations. Be aware of that, just rough approximations. Up next, we have 15 and 1,134, 17, 1,532 for a y value, and finally 19 and 1,890. So as previously stated, now we're going to try to align the best fits. What fits the best? Is it a linear regression? That does not look like a linear regression, does it? Well, it could be, if from your point of view, depending on how you're seeing it, right? So if you prefer to explain as a linear regression, then go ahead and explain it and tell the reason you chose that particular regression line or line of best fits. Could it be exponential or parabolic? It's maybe just a portion of it, right? So this would be an example of a possible exponential or parabolic, in other words, quadratic equation format, right? So from here on, it becomes a matter of trying to explain why you chose that particular form of graphing. Let me bring in my calculator real quick here, and that way we can get a visual for this. So notice we want to be able to plot this. So highly recommend you go back into plotting, and we're going to plot the table here. We're going to go to stats, and we're going to go to edit and enter for edit. If you have any data entered, such as for instance, let's say I have 5, 6, etc. And here I have a couple more values. To get rid of them, you go up to the top, hit clear and push down or enter, and it gets rid of it. Once again, going to the top, hitting clear and down or enter will clear your list. So now we want to enter a list, so we start with 0 for list 1, 3, 6, 9, 12, 15, 17, and 19 is our last value for list 1. List number 2, so going to list number 2, we have 50, 96, 174, 340, 624, 1134, 1532, and finally 1890 would be our last value. And we double check to make sure that we have the same number of data values. Yep, so it means we probably did it correctly. Just a quick glance to make sure I have my values correct for all my list values, and it seems like I might. Yep, seems like I have my values correct. Just a quick glance could always help. So now I'll go to y equals, since I probably already have my initial setup correctly. Just a quick check on my initial setup, stack in y equals. Plot 1 is what I'm going to use. So plot 1 has L1 and L2. That's basically it. And I want to make sure I have dots. So yep, it looks like it's set up correctly. So I just go to y equals again. And from here on, I'll turn it on from here. So I'll go up to number 1 plot, hit enter. I'll push down so I can see it turned on. Right now it's on, it's highlighted. I'll go to zoom, and we want to do a zoom plot. So go down to option number 9. So in other words, it's zoom stat in this case. For my calculator, it's called zoom stat. So option number 9 and hit enter or push the number 9 button. And there we go. We get something similar to what we have over here on our previous graph that we made by hand. Yeah, that looks pretty close. Okay, so then our next step is to try to get regression equations. So let me clear out of this screen. So I'll push the clear button, and we'll go to the stat button, stat. We want to go to the calculate, so I'll go up to the top, go to the right where it says calculate. And the first option is a linear regression, option 4. So I'll go down to option 4 and select option 4, linear regression. And I'll hit enter, enter, enter. If you have a T84, you may need to hit enter several times before it gives you the final answer. For me, I just have to hit enter once. So there it is. And I want to have it enter automatically into my equation. I want y on y1, so I'll go to y equals, push y equals, and go to bars. Bars is next to your clear button or underneath your arrow keypad. So bars, clear button next to your clear button. And we want to go to statistics, option number 5, and I want to go to EQ at the top where it says EQ, and I want to select reg EQ. Hit enter. And there it is. And now I'll graph it to get a brief overview of what it looks like. Graph. And there's my line of s-fits if it's a linear equation. Somewhat close to what I have. Notice my graph is a rectangular shape, so it looks a little bit more extended in the x direction, so something to be aware. But otherwise it's fairly close. Okay, so proceeding on, let's see. I'll go ahead and clear this out so that I'm back on my main screen. Notice I have my linear regression equation still on there from previously, but now I'm going to do another one. So I'll go to stats. Next to your arrow keypad is stats. We'll go to calculate, so calculate at the top. And instead of linear regression, I want to do exponential regression as my next equation. So expreg, let's look for expreg. It's option 0. If you hit enter on option 0 or push the button 0, it automatically gives it to you, but otherwise exponential regression. Look for exponential regression and hit enter. Once again, T84, you have to hit enter several times. T83, just once. And it calculates your regression equation. There it is. So now I'll have a copy once again into my calculator automatically. So I'll go to y equals. I'm at y1 still, so I'll push down so I can be at y2. So I'll push down a few times until you're at y2. Once you're at y2, you want to hit the bars button again next to your clear button, so bars. We want to do, once again, statistics, option number 5, and hit enter. At the top, you want to go to the equation, and reg EQ is your option, so hit enter for reg EQ. And it copies it for you. Do be aware, some T84s do not put an exponent, so you might see a blinking box there, or just a highlighted briefly box on there. I highly recommend you push into the box if it's not in the box and put an X. If it does not show the X, once again, please put an X in your exponent box, okay? And then you can push forward if needed, or you can push down to go to Y3. But for now, I'm going to push graph so that it can show me the line of best fits for an exponential regression. So there is my line of best fits for an exponential regression. It's not bad. It describes it fairly well. Agreed. Okay, so now I'm going to try this again. So let's hit clear. And notice you have the exponential regression statement from before. But we're now going to try a quadratic regression. So go to Stats. Stats. We want to go ahead and do a calculation at the top. So go to the right at the top. And we want to do quadratic regression. So quad reg is our option number 5. So push number 5 or go down to number 5 and hit enter. And it's now if you hit enter, once again, T84s, you gotta hit enter several times until it gives you the answer. But T83s, hit enter once and you get something like this. Once again, be aware, if you get an R square or an R equals, don't worry about those. Those are statistical data. For this particular case, we don't need those numbers. But we still need our equation, which you can then copy your equations onto your paper. Keep in mind, writing the A, V, and C values, and same as from before, do be aware. Recommend you copy your formulas. So, couldn't hurt you rewatch the video and just redo the problem. That way you can recopy the formulas. So now we'll go to y equals though, y equals, and at y3, so let me go down to y3. There it is. And I'm just going to go down a little further, that way you can see that I'm at Y3, to make it a little more clear. Yep, I'm at Y3. Next to your clear button, there's a bars button once again. Select your bars button. You want to go to statistics, option number 5. Hit enter, or push the button number 5. It does the same thing for you. In this case, we want to go to the top, at the top, EQ. And we want to select reg EQ, and hit enter. Notice it now automatically copy your equation. And let's go ahead and push graph to see what this equation looks like on our dots. Hey, look at that. In this case, do you think it makes a better approximation? Once again, plot 1, push up, and it gives you Y3, or you can push down to get Y1, push down to get Y2 to see what Y2 is like, and then down to see what Y3 looks like. Keep in mind, you're also able to turn on and off your equation. So if I go to the right, and notice my cursor's highlighting or blinking where it has the equal sign. I can actually turn off by hitting enter that equation. I hit enter, and notice I push down, and it now goes to the next one, and it starts blinking on the next one. So I hit enter, and now I push down again, and it leaves me only one graph, so I go to graph. Now this is my quadratic equation example. That's what my quadratic equation looks like on there. I'll go to y equals, and I'll go to y2, blink, let it blink where it says has the equal sign, hit enter to turn it on again, and go ahead and hit graph. And now you're going to see the other one, your exponential regression. Which one do you think makes the line of best fits? Which one describes your data better in a sense? Okay, so from now on it becomes a matter of your point of view. What made it a better description? The linear equation, exponential regression, quadratic regression? That'll be entirely up to your point of view and how you want to explain it now. So once again, we went through our 4-step modeling process. We created a scattergram of the data, made a line of best fits, which line worked better, straight line, curve, etc. We can find an equation used in a calculator in many cases, or through previous methods that you may have learned in the past. Step 3, check that the equation is a good approximation to the model, and if it does not fit your model, then pick another model to try to depict it, or another type of equation. Use your equation to draw conclusions and make estimates or predictions. That's step number 4. So once again, we created a scattergram, and here I kind of separated them out so it makes it easier for you to visualize. Which one gives a better approximation? There might not be a right or wrong answer, because sometimes your data could be misrepresented in some cases by some erroneous values. So do be aware of that. But It's your point of view of how you want to explain it now. Model with a quadratic function. Keep in mind, if it's a quadratic function, and just like any other function, does model breakdown occur? Can you have negative values? That's one case scenario where you can have model breakdown. And look for other possible model breakdowns. If you're once again looking at quadratic functions, you might want to determine the vertex, right? So remember the vertex equation, x equals negative v divided by 2a. So once again, from here on, it becomes up to your point of view on which equation and which form you want to describe your data with.